Assalamualaikum and hi. My name is Ahmad Danish bin Matrazi. This is a presentation video for the subject that I'm taking, wastewater treatment technology. I have been assigned to write a report on conventional technologies that have been used to treat wastewater. This report focuses more on wastewater that originates from petroleum industry. Okay, first of all, what is petroleum? Petroleum is a liquid form of energy source that is produced from dead plants and animals over 100 years ago. It happens when those dead animals and plants are buried underneath sedimentary rock and subjected to both intense heat and pressure. Petroleum is commonly used as fuels. It is used in transportation such as diesel engine and to generate electrical energy. There are so many companies that refine petroleum, and in Malaysia, Petronas is one of the companies and is owned by the government of Malaysia.
Refining begins with a process called distilling. After oil is superheated, it becomes vapor. The vapor is fed into the distillation unit. As it rises and cools, the vapor turns back into a liquid. Using stacks of trays, the liquid is easily collected and separated by weight. The lighter and medium weight liquids require less processing before they're ready to be used in cars and trucks. The heavier liquids need more processing to become useful. A process called cracking is used to maximize the usefulness of heavy oil. Heavy oil has long strings of carbon and hydrogen molecules. Using a catalyst, these molecules can be broken into smaller chains, transforming the heavy oil into lighter, more valuable fluids. Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but their structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable, gasoline-like molecule. Blending is a process of mixing different refinery products to make finished petroleum fuels. Gasoline, for example, is blended to achieve octane standards, creating the grades of gasoline you see at the pump: regular, mid-grade, and premium, that are necessary to meet the needs of specific engine types. Treating is a process used to produce cleaner gasoline, which helps protect both the environment and our health. Gasoline molecules contain impurities like sulfur that can be removed. When the molecules are heated and come in contact with a special catalyst, a chemical reaction occurs that strips the sulfur away. These sulfur compounds are used as fertilizers and in pharmaceuticals. Nothing goes to waste in a refinery.
Next, we are going to talk about the pollutions that happen due to refining of petroleum. As can be seen in the picture, it can cause air pollution. Petroleum refineries are a major source of hazardous and toxic air pollutants such as BTEX compounds, which are benzene, toluene, ethylbenzene, and xylene. They are also a major source of criteria air pollutants such as nitrogen oxides, carbon monoxide, and hydrogen sulfides. Refineries also release toxic hydrocarbons such as natural gas methane and other light volatile fuels and oils. Some of the chemicals released are known or suspected cancer-causing agents responsible for developmental and reproductive problems. The second type of pollution caused by petroleum industry is water pollution. Water pollution can happen when there is oil spill in the ocean. This can happen due to incidents that come from human mistakes and careless. The oil will cover the surface of the ocean and prevent oxygen from entering. This can lead to the death of animal and aquatic plants. Next, we will go to the first journal. The first journal uses microwave-assisted catalytic wet air oxidation under low temperature and pressure. This is a type of hydrothermal therapy. This treatment method is normally used to treat non-biodegradable molecules, and in this case, hydrocarbon molecules from petroleum. The pressure needs to be maintained during this treatment. Alright, so the second journal uses precipitation process by using coagulant. Basically, all the particles that need to be removed are accumulated together, forming larger particles called flocks. There are so many types of coagulant that can be found in industries, but the most common is inorganic metal-based coagulants. Now, we will go to results and discussion. The table shows the results for both journals. For Journal 2, there are several coagulants being used, so I choose only 2 for this report. There are 3 parameters that have been analyzed, which are chemical oxygen demand, temperature, and pH value. For COD value, we can see that result from Journal 2 that used aluminum sulfate as its coagulant has the highest value. But overall, none of them exceed the standard set by DOE. Next, for temperature, we can see that the highest temperature is read from Journal 1. Therefore, it needs more time to be cooled down before it can be discharged. Both results from Journal 2 does not exceed limit set by DOE. For pH value, both results from Journal 2 show natural pH value and still in the range set by DOE, but no pH value can be found in Journal 1. As can be seen in the picture, both Journal 1 and 2 have their own advantages and disadvantages. The usage of catalysts in Journal 1 has reduced the other expenses such as energy consumption. The disadvantage is that the temperature is high and more time is needed to cool down. For Journal 2, it has lower temperature, so it does not need more time and can be discharged. The disadvantage is that the usage of coagulant has its side effects such as corrosion in the pipelines. As the conclusion, there are so many ways in industries that can be used to treat wastewater by petroleum industry. Every method has its pros and cons. The best solution should be applied to cut costs and save the environment.